Hello everyone, in this video we are going to talk about the shielding effect. So let's start. So we're going to start with the two main forces that act on all the electrons within an atom. So the two forces that occur within an atom are attractions. Electrons, being negatively charged particles, they are attracted by the protons in the nucleus. So protons have a positive charge. So unlike charges attract each other, that's why all the electrons in an atom are attracted by the protons in the nucleus. So in other words, we can say nucleus attracts or creates a pull on the electrons. The second type of force that occurs within an atom is the repulsions. Repulsions are between the electrons, right? So both, like, electrons are repelled by other electrons in the atom because they both have negative charges. Like charges repel each other, right? So in order to start, we need to know what are valence electrons, right? So what are valence electrons? The electrons in the outermost energy level of an atom are called valence electrons, right? So if we look at group 1 elements, group 1 elements have one valence electron, group 2 elements have two valence electrons. You can see all the group 1 elements have one valence electron, group 2 have two valence electrons. So look at the number written in front of the alphabet. That actually tells us the number of valence electrons, right? So now let's see for ourselves like how to calculate the valence electrons. So that is very important in order to know the shielding effect. Here I have drawn three different atoms: lithium, sodium and potassium. So now you can see that lithium has lithium has one valence electron, sodium has one valence electron and potassium has one valence electrons. So they all are group 1 elements. They all have one valence electron, right? Now you can see that. So I have drawn the number of energy levels and then I have shown the valence electrons in red, right? So now look. So if we look at the periodic table, lithium is in period 2 and then sodium is in period 3, potassium is in period 4, right? So lithium has two energy levels and within those two energy levels we have to distribute the 3 electrons, right? So we have to draw two energy levels, n equals 1 and n equals 2. Since lithium has 3 electrons, so we'll put 2 in the first. So the configuration is 1s2, 2s1, right? So 2 electrons in n equals 1 and 1 electron in n equals 2, right? With one valence electron. Now let's draw the board diagram for sodium. Sodium is in third period. So it has 3 energy levels, right? So we have drawn 3 energy levels for sodium, n equals 1, 2 and 3, right? Now since the configuration of sodium is 1s2, 2s2, 2p6, 3s1, right? So now n equals 1 has 2 electrons, n equals 1 has 2 electrons and n equals 2 has 8 electrons and n equals 3 has 1 electron, right? So the outermost energy level is n equals 3. It has one valence electron, and same is true for lithium. It is 1s2, 2s1. n equals 1 has 2 electrons and n equals 2 has only 1 electron, right? So they all have one valence electron that I drew in red. Okay, so we distributed the 11 electrons of sodium within 3 energy levels. Energy level 1 has 2, energy level 2 has 2 plus 6, 8, so 8 electrons, and energy level 3 has only 1 electron, and that is the valence shell, right? So the outermost energy level, n equals 3, this is called the valence shell or valence energy level, right? Now let's go to potassium, which has atomic number 19. It has 19 electrons and it is in the 4th period. It's in the 4th period and group 1 of the periodic table, group 1 4th period, right? So it has 4 energy levels. If we write down the configuration, so it's 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. So n equals 3 has 8 electrons, n equals 2 has 8 electrons, and n equals 1 has 2 electrons, right? So n equals 1 has 2, n equals 2 has 8 electrons, n equals 3 has 8 electrons, right? And n equals 4 is the valence shell. Right? So they all have 1 valence electron. Now when it comes to shielding and the shielding effect, now look, all the electrons in the innermost energy levels, right, they are blocking the pull of protons from the valence electrons, right? Now the protons in the nucleus, they are attracting on all the electrons, right? But this, look at this pink electron, right? That's the valence electron in lithium. So that is blocked by these 2 electrons. These 2 electrons are like shields, right? They are blocking the pull of the nucleus from this pink electron, the valence electron, right? Now let's look at sodium. Sodium has 11 protons in the nucleus, right? Now these 11 protons are attracting all the electrons, right? Now look at this valence electron. This valence electron cannot experience the full pull or attraction of 11 protons because there are in between electrons, the blue electrons, they are kind of shielding the pull of 11 protons from this valence electrons, right? And then in sodium, these 19 protons are pulling on all the electrons, but this valence electron is kind of shielded from the nuclear pull by these 18 electrons, right? So now you can see that there are 18 shielding electrons and there are 10 shielding electrons in sodium and there are 2 shielding electrons in lithium. So as we are going down the group, you can see the shielding is increasing. The shielding is increasing from top to bottom in a group, right? Now let's look at the number of energy levels. So the number of energy levels as you go down increases from top to bottom in a group, right? So now this way the energy levels are increasing. Right? Number of shielding electrons are increasing. Right? So with each group, within each period, right, the number of energy levels stays the same, but as we are going from top to bottom in a group, the number of energy levels is increasing and so are the number of shielding electrons. You can see that lithium has 2 shielding electrons, sodium has 10 shielding electrons and potassium has 18 shielding electrons, right? So now as we are going down, the distance of the valence shell increases from the nucleus. Nucleus is in the center. Look at the valence shell. So N equals 3 is the valence shell in sodium. The distance of the valence shell is increasing from the nucleus. It's getting away and away, further away as you go down in the group, because we are adding one whole new energy level, right? So what happens? So shielding increases as you go down in a group, right? Now, since the valence electrons are getting more and more shielded, right, the nuclear pull cannot be felt by the valence electrons, right? So because of that reason, they are not attracted strongly to the nucleus, and this trend increases as we go from top to bottom in a group, right? So all you have to know for the shielding effect is shielding effect increases from top to bottom in a group because energy levels increases from top to bottom, and since there are more and more energy levels as we are going down, the number of shielding electrons is increasing, right? And the distance of the valence shell increases from the nucleus. So the valence electrons, they are less and less attracted as to the nucleus as we go down, right? So in cesium, they are the least attraction of valence electrons to the nucleus. In lithium, the valence electrons are strongly attracted to the nucleus. So the attraction of the valence electrons to the nucleus decreases down the group because of the increasing energy level, increasing number of energy levels, and because of the increased shielding, because of the more number of shielding electrons within an atom as we go down in the group, right? So hope that video is helpful, and I'll see you in the next video for the Z effective and effective nuclear charge. Bye.